When the First World War ended, the U.S. Army found itself with thousands of water-cooled Browning M1917s, powerful but cumbersome weapons that had to be lugged around with hoses and cans of coolant. In the mud and dust of France, they had worked. In the lean budgets of the 1920s, they were a liability. The interwar years forced American ordnance officers to ask a simple, practical question. Could a gunner get the same reliability and volume of fire without dragging a bucket of water? That question would launch the long journey to the M1919 Browning, a gun that would become one of the most recognizable machine guns of the 20th century. The man who made it possible was an unassuming Canadian-born engineer named John Moses Browning. By the time the U.S. Army adopted his air-cooled M1919 variant, Browning had already designed shotguns, pistols, and machine guns for Winchester, Colt, and Fabrique Nationale. But the trick that turned his heavy water-cooled M1917 into a light, reliable battlefield tool lay in a subtle manipulation of physics, the recoil-operated short-recoil principle. Instead of using gas taps, Browning harnessed the backward energy of each shot to cycle the next round. It was elegant, compact, and above all, self-contained. No tubes to clog, no coolant to freeze. In the early 1920s, the U.S. Army Ordnance Department began testing lighter housings for the old M1917. Removing the water jacket cut more than 20 pounds, but heat remained the issue. Browning's team replaced the solid jacket with a perforated barrel shroud, letting air circulate around the steel while the weapon fired. Gunners could now carry the weapon across open ground, set it up on a tripod, and deliver the same .306 firepower without the logistical burden. Tests at Aberdeen Proving Ground proved the concept. A gunner could fire 250-round bursts before overheating forced a pause, more than enough for infantry suppression in the mobile warfare that strategists predicted for the future. When the Great Depression hit, American military funding collapsed, and so did large-scale production. But the prototypes remained on the shelves of Colt's patent firearms manufacturing company. By 1933, rising global tensions gave ordnance officers reason to revisit the design. The air-cooled Browning became the M1919A1, and soon after, engineers at Rock Island Arsenal refined it into the M1919A4, the version destined for World War II. The short recoil system stayed identical to Browning's 1917 layout, barrel and bolt recoiling together a short distance before unlocking, but small details changed everything. A new barrel extension, an improved buffer, and interchangeable parts that made mass production possible on Ford-style assembly lines. By the late 1930s, the Army knew it had found the ideal balance between reliability and mobility. A trained crew could strip and reassemble the gun blindfolded in less than 2 minutes. Its 500-round-per-minute rate of fire bridged the gap between rifle and heavy machine gun, and crucially, Browning's recoil trick meant it could operate flawlessly in sand, snow, or rain, conditions that doomed many gas-operated weapons of the era. As Europe descended into war, the M1919's simple genius, energy turned inward to sustain itself, embodied the American industrial philosophy, do more with less and make it last. When World War II erupted in 1939, America had not yet entered the fight, but its factories were already humming. The Browning M1919 was ready to move from test ranges to real battlefields. Air-cooled design meant it could be mounted anywhere on jeeps, half-tracks, tanks, and aircraft. When U.S. troops finally went overseas after Pearl Harbor, the M1919 was the dependable gun they trusted to keep working when everything else broke down. The M1919 fired the same .306 round used in the M1 Garand rifle. This made ammunition supply simple and helped the entire U.S. Army use one cartridge for both rifles and machine guns. Its belt-fed system allowed long bursts of fire that pinned down enemy positions while infantry advanced. The gun weighed around 31 pounds without its tripod, heavy, but light enough for a 2-man crew to carry. One man fired, the other fed ammunition and replaced barrels when needed. The system was straightforward, and soldiers loved it because it simply worked. The gun's heart was still John Browning's short recoil idea. When a round fired, both the barrel and bolt slid backward together for a short distance. Then the barrel stopped, the bolt kept moving, and the spent case was pulled out and thrown clear. A new round slipped in from the belt, the bolt closed, and the gun was ready again. There were few moving parts, and they were strong. The design could take mud, sand, or even snow, and it would keep going. Gunners soon learned they could fire hundreds of rounds before problems appeared. In North Africa in 1942, American machine gun crews discovered that the desert heat punished both men and weapons. The M1919's open-barrel shroud helped it survive those conditions far better than the water-cooled guns that other nations still dragged across the sand. British units under General Montgomery mounted the gun on their desert jeeps, while American Sherman tanks used twin or triple versions on their turrets. Whether it was mounted on a truck or dug into a foxhole, the rhythm of its firing, a steady metallic clap at 500 rounds per minute, became the sound of advancing Allied troops. When the war moved into Europe, soldiers found new challenges. The cold, wet forests of the Ardennes froze many automatic weapons. The M1919 kept firing. Crews learned to keep the bolt forward when idle, wrap the gun in canvas overnight, and clean it only when needed. It was a weapon built for field conditions, not laboratory perfection. Engineers in the U.S. called it soldier-proof. In places like Normandy, Aachen, and Bastogne, it lived up to that name. Every major Allied advance, from the beaches of Sicily to the hedgerows of France, had the M1919 behind it. Machine gun teams formed the backbone of each infantry company, setting up fields of fire that let the riflemen move. The weapon was not glamorous, but it earned a quiet respect. Soldiers said it gave them confidence that no matter what came through the smoke, they had the firepower to answer. By 1944, the Browning M1919 had become more than a machine gun. It was part of the U.S. soldier's identity. Whether carried by infantry in Italy or bolted to aircraft wings over the Pacific, it served in almost every branch of the American armed forces. On Sherman tanks, the M1919A4 sat coaxially beside the main cannon, giving tank crews a way to cut down infantry without wasting shells. Air crews fired the lighter M1919A4 and M1919A5 versions from the waist, nose, and tail of B-25 Mitchell and B-17 Flying Fortress bombers. The same recoil system worked perfectly in the air at freezing altitudes where lubricants froze and gas systems failed. The Navy and Marines soon found new uses for the gun. Mounted on patrol boats and amphibious landing craft, it provided cover for troops racing ashore. On the beaches of Tarawa, Saipan, and Iwo Jima, the air-cooled Brownings poured fire against Japanese pillboxes, often running until the barrels glowed red. The design's simplicity meant a quick swap, pull a latch, slide in a new barrel, and keep fighting. Marines appreciated its dependability, especially during Long Island campaigns where spare parts were scarce. One remarkable feature of the M1919 was how easy it was to adapt. Engineers turned it into a tank gun, a plane gun, and even a flexible anti-aircraft weapon. It shared many parts with its big brother, the water-cooled M2.50 caliber, so supply chains stayed simple. The two weapons together formed a complete system, the M1919 handling infantry work, the M2 covering heavier targets like trucks, boats, and aircraft. That pairing gave Allied forces a huge advantage in logistics and battlefield versatility. As Allied armies pushed into Germany, the gun's reliability became a legend. In the Battle of the Bulge, snow covered foxholes and jammed rifles, yet M1919s kept firing. Crews melted snow in their helmets to pour water over overheated barrels. When one barrel warped, another could be fitted in seconds. In ruined towns like Bastogne, gunners set up M1919s in windows, using them to hold off enemy armor and infantry until reinforcements arrived. Even after Germany fell, the gun remained everywhere. In the Pacific, its final test came on Okinawa, a brutal battle that lasted from April to June 1945. There, U.S. soldiers and Marines again used Browning's recoil system to hold their lines under relentless attack. In that humid, rain-soaked environment, gas-operated guns often jammed, but the M1919's short recoil mechanism ignored the weather. As one Marine put it later, it was ugly, it was heavy, but it never quit. When the war ended, the U.S. military had built more than 400,000 M1919s. They filled arsenals around the world, and the design's solid performance guaranteed it would not disappear with victory parades. America now had a proven weapon that could be refined, modernized, and used in the next inevitable conflict. When the guns fell silent in 1945, the Browning M1919 did not retire. Instead, it became the standard machine gun of the U.S. military through the start of the Cold War. In the years after World War II, engineers at Rock Island Arsenal began modernizing it for new roles. They converted the wartime .306 version to fire the newer 7.62x51 NATO round, giving it the name M1919A6 and later M37 for armored vehicles. This new cartridge burned cleaner, recoiled slightly less, and matched ammunition used by Allied nations under the NATO standard. The change meant the M1919 could serve side by side with British, Canadian, and West German units without supply problems. When the Korean War broke out in 1950, the same guns that had crossed the Rhine were shipped to Busan and Incheon. American and United Nations troops faced brutal winters and steep hills. In those frozen trenches, the M1919 again proved its worth. Crews learned that oil thickened in the cold, so they used dry graphite on moving parts. The recoil system stayed dependable, cycling smoothly even when temperatures dropped below zero. Many veterans of World War II said it was the one weapon they trusted most when conditions turned against them. During the long seesaw battles across the Korean peninsula, Browning's machine gun filled multiple roles. Infantry squads used it on the ground for defense, while tankers used the M37 coaxial version inside Sherman and Pershing tanks. Engineers mounted it on jeeps for mobile fire support. Its modest rate of fire kept ammunition use reasonable, an important advantage when supply lines were stretched thin over mountains. Soldiers called it the workhorse, a name earned by consistency rather than glamour. By the mid-1950s, lighter designs like the M60 were being tested, yet in many corners of the world, the M1919 stayed in service. Allied nations such as Israel, South Korea, and the Netherlands continued to field and modify it. The Israelis even rechambered it for 7.62 NATO and mounted it on Sherman tanks and armored cars during the Six-Day War. Its air-cooled barrel and recoil mechanism still performed, even in the heat and dust of the Middle East. In training bases back home, young American gunners still learned on the M1919. It had become the old reliable, simple enough to teach the basics of machine gun theory, recoil, headspace, timing, and control. Instructors used it to explain how energy transfer worked, how the recoil spring and bolt balanced one another perfectly to keep the gun in rhythm. Many of those same lessons would shape the next generation of weapons. As the Cold War deepened and the United States faced new kinds of wars, smaller, faster, and more mobile, the M1919 began to seem heavy by comparison. Yet no other gun had served so long or across so many environments. Its principle of recoil operation continued to influence every automatic weapon that followed. Browning's century-old idea remained at the heart of American firepower. By the time the Vietnam War began, the Browning M1919 was no longer the star of the American arsenal, but it was far from forgotten. Many units still carried it as a secondary or mounted weapon, especially during the early stages of the conflict in the early 1960s. The newly introduced M60 machine gun had replaced it as the standard general-purpose weapon, but the M1919's air-cooled design and recoil system remained trusted by older gunners who knew its rhythm. The gun's lineage appeared everywhere, from the coaxial mounts of tanks to the door guns of helicopters and river patrol boats. In the hot and humid jungles of Southeast Asia, reliability meant survival. The M1919's recoil action had already proved itself in 2 world wars in Korea. Even with limited use, the weapon's legacy lived on through design lessons that shaped the M60 itself. The U.S. ordnance engineers had studied the M1919's short recoil balance when developing the M60's operating group. The goal was to merge Browning's simplicity with lighter materials and belt-fed mobility. Although the M60 borrowed some concepts from the German MG42, its roots in Browning's mechanical logic were unmistakable. The idea that energy from each shot should power the next with minimal complexity. In Vietnam, some South Vietnamese and Allied units continued to use refurbished M1919s supplied through American military aid programs. These guns had been built 2 decades earlier but still functioned perfectly. Mounted on jeeps and armored personnel carriers, they delivered steady suppressive fire in ambushes and convoy escorts. A few American advisors, especially those from earlier deployments, preferred the Browning because of its predictable recoil and manageable rate of fire. In wet tropical conditions that jammed newer weapons, the old M1919 often remained operational. At air bases and outposts, the gun also found new life as a static defensive weapon. Crews mounted them on sandbag positions, aimed down airfield approaches and perimeter fences. When North Vietnamese sappers attacked during the Tet Offensive, those same aging M1919s barked again, defending airstrips at Da Nang and Bien Hoa. Even after decades of service, Browning's design refused to die quietly. The weapon's recoil trick was its true inheritance. Every generation of American automatic gun that followed the M2, M60, and later the M240 owed something to Browning's engineering logic. It was the idea that reliable motion mattered more than raw firepower. Soldiers who had grown up hearing the rhythmic beat of the M1919 in training now recognized its echo in the weapons they carried in Vietnam. By the late 1960s, most surviving M1919s had been relegated to National Guard units, training depots, or sent abroad as military aid, but the design continued to evolve. Civilian gunsmiths rechambered surplus examples for semi-automatic use, while foreign armies kept them in active service. In Israel and Latin America, they remained front-line weapons well into the 1980s. Few guns in history could claim such longevity, nearly 70 years of combat use powered by one man's understanding of recoil and motion. Today, the Browning M1919 stands as one of the longest-serving machine guns in history, not because of flash or speed, but because of function. John Browning's recoil system, developed before most of the soldiers who used it were even born, gave the weapon a heartbeat that never faltered. Each shot drove the next, using the very force of recoil to keep the mechanism alive. It was a simple idea, but one that outlasted complex competitors. In an age of electronics and composite materials, the M1919 still fires with the same dependable rhythm it had in 1919. Collectors, historians, and veterans continue to revere it not just as a weapon, but as a work of mechanical logic. The short recoil operation, where the barrel and bolt move backward together before unlocking, remains a cornerstone in automatic weapon design. It proved that reliability could be engineered, not hoped for. No gas pistons to clog, no fragile springs to tune, only strong steel parts working in perfect balance. The recoil energy that most designers feared became Browning's greatest ally. In post-war decades, engineers around the world studied the M1919 to understand why it worked so well. Belgium's Fabrique Nationale used its principles to develop the FN Mag, later adopted by the US as the M240. Even the modern M2HB, still used on American vehicles today, shares the same DNA. Every pull of a modern machine gun trigger, from Afghanistan to training ranges in the US, echoes that same mechanical logic first drawn on Browning's blueprints in 1917. What truly made the M1919 a legend was its adaptability. It served in the trenches of France, the deserts of North Africa, the jungles of the Pacific, the snowfields of Korea, and the rice paddies of Vietnam. Few machines have spanned so many generations of war with so few changes. Soldiers who manned it in 1944 could easily operate 1 decade later with almost no retraining. That continuity made it a silent link between eras, a bridge between the industrial wars of the past and the mechanized conflicts of the modern age. In museums and memorials, the M1919 now sits on its tripod, oil dark and solid, its perforated barrel shroud scarred from use. Veterans recognize its sound instantly, a steady clatter, not frantic but firm, like a heartbeat under pressure. For them, it recalls the smell of cordite, the weight of a linked ammunition belt, and the comfort of a gun that never failed when it mattered most. John Moses Browning passed away in 1926, long before his design became a legend. Yet his recoil trick, the insight that motion itself could sustain a weapon, became one of the cornerstones of modern firepower. The M1919 was his proof that simplicity, if done perfectly, could outlast empires. From the beaches of Normandy to the jungles of Vietnam, it spoke with the same voice, steady, reliable, unmistakably American.